Hello, my name is William Post, and I, along with my teammates Paul Sporen, Jonathan Bach, and Max Deo, are a member of HACC Overflow, a team competing in the 2019 Hawaii Annual Code Challenge. For this year's HACC, we chose the HECO Electric Vehicle Charging Station Analysis Challenge. Now, this challenge was to develop an application that featured a dashboard that displayed the health and key metrics of various electric vehicle charging stations that were operated by the Hawaiian Electric Company. We hope this video will demonstrate some of the awesome features that we put into our application. The application is made up of two components: the dashboard for administrators to monitor and analyze real-time data from various charging stations, and a user-facing app for electric vehicle owners to find the closest open station. These components work together to provide better insights for both customers and administrators. Let's take a look at our dashboard. Each station is being simulated using past station data that was made available to us for the competition. We've made assumptions that station data will eventually be transmitted in real time. Our simulated stations make requests against a central server, which is listened to by Prometheus, an open source toolkit for monitoring real-time data using a time series database. Now, we're also leveraging another really awesome open source tool called Grafana. Grafana is great for data visualization and data analysis, especially for real-time data like the one that's made available when we use a tool like Prometheus. Let's talk about some of the metrics we're monitoring here. Note that we are visualizing data from the last 6 hours, but this time window can be changed at any time. Here we see the current total watts being delivered by all stations. Here we see the breakdown of different payment methods and how the sessions are being initialized. Here we have a time series graph showing each station's kilowatt distribution over time. Since we were only given total kilowatt hours delivered per session, we used a curve fitting tool to generate a function who shared the shape of a graph that was given to us for the competition, but also a function whose integral equaled the total kilowatt hour that was delivered. Here we see the longest stretches of times between charges. If any station goes longer than that 14-hour threshold you see, that flat bar, an alert is set notifying administrators that has probably been an issue. Here we see the general health status of each station. If a station is no longer able to make requests against our server, then an administrator will be notified. Our last two metrics are related to the client-facing app. Here we can see how many searches have been made in our time window for the nearest available station. Finally, we have our map component, which measures the location and frequency station lookups are being made. We can use this data to get a good idea of where maybe a new station should be installed. Note that each metric can be examined more closely. In fact, we have the full power of Prometheus's querying language to examine the data in really innumerable ways. Let's head over to our client-facing app. Here we can see markers for each station, and the color of the markers indicates the station's availability. Note, for the purposes of the demonstration, we hard-coded each station's availability, and it's not reflecting our backend service. We can click on the station to get directions, check its availability. We can use our current location to find the stations nearest us. Or we can search for a location instead. Note that every time a search is made, our backend service is notified. Well, that about wraps it up. We just want to say that we chose this project because we believe in clean energy, and we want to help satisfy our community's clean energy needs. We have a lot more work to do, but we hope that you're as excited as we are about this project. Thank you.